All right, section 3, alcohols. Now, what we're going to be talking about is this portion right here. So, what is an alcohol? What is primary, secondary, and tertiary? And then finally, we're going to go to the oxidation bit where I'm going to give you guys mostly stuff to research for it because it's mostly about the conditions more than the theory. So, you don't need to know about the mechanism of oxidation. You just need to have an idea of what can we add to oxidize alcohol to make an aldehyde, carboxylic acid, or a ketone. That's basically it. Nice and simple. Checklist I've got for you is right here. So again, you can use this to help you make sure that you've got everything in your assignment. Detailed definition, again, goes back to using those websites that I mentioned before. Learn the information, write it down, and then type it up. That for me is good enough, so long as you're writing something that's coherent and I can understand it. If you're writing stuff that's way above the level that you're at, I'm going to know straight away that it's not your information. I need you to be able to understand this because it's your handbook. So if you're not understanding these things and you're talking about things that are way above your level, I'm already going to know. So please just stick to the information that you need. Nothing more, nothing less. Give me an example of what an alcohol looks like. It's going to look similar to this page here, like that. And then you're going to talk to me about, again, primary, secondary, tertiary. Use a similar format to that you did last time. And then we've got some oxidation reactions, which I'm going to give you an overview or a way to structure those in your assignments. So let's go straight to alcohols. And again, we got a very similar page to last time where we know that the alkyl group, the carbon set, is going to be delta positive. This is because the oxygen is very electronegative. So it's going to be pulling those electrons towards it. And that means that this is going to be exposed to attack by nucleophiles. Also, what we have in this is that the OH itself is another very delta positive, delta negative shift, and that'll take part in other intermolecular bonding, and this is a H bond. So what you'll find with alcohols is that they tend to have much higher boiling points and melting points because they take place in H bonding. That doesn't make a difference to our reactions, it's just some physical properties that you might want to know about. So the OH is a hydroxy group, and alcohol is where we replace one of the hydrogens in an alkane with an OH group. The O is in group 6, which is highly electronegative. OH groups are electron withdrawing. They're also known as hydroxy groups, or hydroxide groups, because it's just an OH. But these are alcohols. Alcohols are polar molecules, means it's a permanent dipole. Means that the C delta plus is good from attack from nucleophiles, like I mentioned before. Things that are slightly or more negative, and therefore interested in something positive. So it's going to use those lone pairs to attack this carbon center here, which could then eliminate this oxygen, and we see something come out of that. Nomenclature in order to name an alcohol, quite simple. Most of you guys seem to remember this. An alcohol is named with the suffix -ol. Suffix means at the end of the word. So -ol, we got a carbon stem and then -ol. So methanol, ethanol, propanol, butanol, pentanol. If you've got a secondary or tertiary alcohol, you need to remember to number where that hydroxyl group is. So in this example down here, I've given you a bit of a weird one. So I've given you a 15 carbon chain just for the sake of it. And then on this, what I've done is here, I've drawn a tertiary one. You've got 7 methyl, 7 pentadeca, 7 ol. Yes, that is what it's called. And if you look at the numbering system, we would go 1, 2, 3, 4, 5, 6, 7, 8, 9. But I've called it 7 because we always name it from the smallest carbon chain. So just remember that when you're checking your diagrams to make sure that your carbon numbers match up. You don't need to number your carbons like I have. I've just done it here to show you. And you can see that this methyl group here is this methyl group here. This little dot at the very end of this line represents CH3. It's just a short way of us writing it, so we don't have to write CH3 at the end of everything, because otherwise it takes forever. And that's why we do it shorthand. I just want to clean this up. There we go. So if you need to name it, that's how we're going to name these things. Just remember for tertiary, you're going to have some form of alkyl branch, like a methyl. You'll have a methyl group in there. If you don't have a methyl on your tertiary, you don't have if you don't have an alkyl group in your tertiary name, it is wrong. You need to double check that. Again, use this table here just to make sure that you've got the naming system. But again, you can use my cheat sheet. But for the most part, that's an alcohol for you. There's not really much about it other than we have this polar bond, which means that the R group is susceptible to attack by nucleophiles. And we have hydrogen bonded between this alcohol. Again, nothing special. Primary, secondary, tertiary, we're going to go back to using the same system as I mentioned earlier on, where this time we have a hydroxyl group that's bonded to a carbon, and how many carbons are bonded to that? 1, so therefore it's primary. This time we have a hydroxyl group bonded to a carbon, and how many carbons bonded to that? 1, 2. Therefore, it is secondary. And now I have a hydroxyl group bonded to a carbon, and this carbon is bonded to 1, 2, 3. So that is tertiary. And I'm just going to clean this up. So that's how you need to make sure that you name them primary, secondary, tertiary. Now, one thing I like to do is I like to highlight or label my molecules if it's primary, secondary, or tertiary. So you can see here when I named this one, I just started it with a 3. It's like looks like a 3 degrees symbol, but 3 naught for tertiary. Now, next thing I'm going to talk about is oxidation reactions, and I've given you the general idea or the general outline for what most of these reactions are going to look like. You're going to only have 3 that you need to write about, and they could probably fit on 1 page. I would try and fit them onto 1 page. If not, do it over 2 pages, but make sure the sections look clean. And remember, it's a handbook meant to be read by 16 to 18-year-olds, presented clearly. I'm just going to zoom in on here, and the first reaction we're talking about is a partial oxidation with a primary alcohol to form an aldehyde. So over here, you're going to give me a primary alcohol. Any primary alcohol, just pick one, make sure you draw it and name it correctly. This O in brackets means some form of oxidizing agent. That's all it means. It just means an unspecified oxidizing agent. What you're actually going to do is you're going to specify the oxidizing agent as part of your conditions. And there is another set of conditions that we need there as well. So find out, for a partial oxidation for primary alcohol to an aldehyde, what conditions are needed. And you can basically search that up using, again, the references I've given you. ChemGuide definitely has them because I've seen it. So when you're messaging me like, oh my God, I can't find the information. It doesn't exist on the internet. It does. Just look it up. Just Google it. Look, Google that and you'll find it. Simple as that. The next thing we're going to do is we're going to write our aldehyde. And because I've not introduced aldehydes to you guys formally yet, I'm going to mention a little bit here of how to name that. So whatever your stem is over here, so let's say, for example, you did, what did I do before? Pentadeca. So if I did pentadecanol and then oxidized it, over here, I would have pentadecanal. So I'd have pentadecanal. That's how it would name, and that would be my aldehyde over here. And then obviously we're going to have our water there. I don't think it's me cheating telling you guys that H2O is water. If you don't know that, probably shouldn't be doing chemistry. Second reaction, again, give me another example where I have a complete oxidation. I've even balanced it for you, big 2, with a primary alcohol to a carboxylic acid. So again, you're going to do the same thing where you give me a carbon chain, you give me a primary alcohol, and then you name it over here. And I've given you some examples. Your stem, anoic acid is what it's going to be called. So methanoic acid, ethanoic acid, propanoic acid, pentadecanoic acid, if that would even react. But yeah, you get the idea. And then for a secondary, you got a complete oxidation with a secondary alcohol to a ketone. It's important here that you do have a secondary ketone. It must be greater than 2 carbons because you can't have methanone and ethanone. So you need to have at least propanone, butanone, pentanone, and so on and so forth. Or you could have pentadecanone like I did before. These little red squiggles, you'll see a lot of this in my drawings. This is just garbage. It's nonsense. It's just honestly a squiggle to represent an R group. Just because I think if I was to do something like R, C, O, H, C, R, I think most of you would end up crying. It's not very clear. It doesn't really make any sense. I've omitted the hydrogens anyway. So none of this doesn't... I think it makes it more difficult for you guys to understand. Whereas what I've done is I've just done a wiggle. Remember, when you guys are drawing yours, they need to be straight, lined, and connected. Much clearer like that. If you have something that looks like this, it's wrong. They need to be connected. If you're saying that your structures are wrong, it's because they're not connected. You need to make sure they are all connected. A common mistake that we also see when it comes to nomenclature is, let's say, for example, you do something like this. Some people go 1, 2, 3, 4 carbons, OH, butanol. That is wrong. This right here is not a carbon. We've got a carbon here, a carbon here, a carbon here, and this carbon is bonded to an OH. So we only have 3 carbons in that. So that's how you would name that. So just make sure that you're not making those mistakes. And then over here, for all ketones, they end in -one, depending on your stem. So propanone, butanone, pentanone. Propanone is also known as acetone. So if you've got acetone in your work, I will accept it. I'm just not a big fan of it. Again, you just need to find the conditions for this and this, 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 and this. Once you put together your own reactions, that's this stage done. And then I've got some information here, which just reiterates what I said before. But that's oxidation reactions. And again, you can see the reference. So just make sure that you're referencing each of your work. But keep it up.